Hey, hi. So I figured since it's so much easier to show you, maybe I would try videotaping. See, look, I already set it up. It's very pretty. Okay, so here's the original. I labeled it 1, 2, wait, I'll gesture. 1, 2, 3, and 4 because 2 is just represents the combination of these two. And then this is the one where those two are actually combined into that. So I'll write 2 right here. And then 1 right there, because this is just 1 transferred over. Okay, so we already combined these two into that, but I'm going to do it again because I didn't actually combine it. So it's 1 over 4 plus 1 over 6, which equals something that I don't know. Oh, it equals 2.4. Okay. It equals 2.4. So then this right here is going to be is going to equal 2.4 ohms. Okay? Now we want to find the total ohms, or the total amount of resistance in this. So we're just going to do, since this is a series circuit, in a series circuit you find the resistance by adding the littler resistances. So we're just going to do 2 plus 2.4, and even I can do that in my head, get 4.4 ohms as the total. So we'll write that down here and we'll do R total equals 4.4. And then you can see, oh, I forgot to write this on. Over here, okay. Over here, this is the original picture. 48 volts is the voltage. So it's the same thing in my second really pretty picture. 48 volts. And this is the total volts for the entire circuit. So volts total equals 48. Before I keep going, I want to start filling in my pretty chart here. So you can see that 1, the resistance for 1 is 2 ohms. The resistance for 2 we just found, see, 2 we just found is 2.4 ohms. And that's all we've found so far. So now we have total resistance and total voltage. So we have the equation that's V equals IR, and that's going to be used over and over and over again. So we have V and we have R, so we're going to go, and we want to solve for I, total I. IT equals question mark. So we're going to do V equals IR. We know V, that's 48, equals I times R, which is 4.4. And you do 48 divided by 4.4, and I total comes out to be 10.91. 10.91. Okay? You just plug that into your calculator. So now we have the total values for everything, which seems pretty silly because they're total, but you can remember that that in a series circuit, which we have right here, the current is constant, which is what we just found. See? Box. So 10.91 is not only the current for the total circuit, but it's also the current for each individual. So this is amps. So for for resistor number 1, the current is 10.91 amps, and for resistor number 2, it's also 10.91 amps. Now we can solve for voltage in each of these two things, because see, we have amps, which is the current, and we have ohms, which is resistance, and we go back up to our nice happy equation. Do another box. Doing this through a camera lens is really difficult. And so we go back up to this equation and we do V equals IR, so we can literally just multiply these two together. So I'm not writing it out for you. So that comes out to be 21.82 volts. And then down here you do the same thing, you just multiply these two together. And this comes out to be 26.184 volts. So we can fill in some more values in our table now. We have, for 1, we now have the current being 10.91. So we go down here, and we go 10.91, and we see that the voltage is 21.82. So we go down here and we say 21.82. Okay? And then you go over to number 2, and you see that the current is 10.91. So you plug that in. And then you see that the voltage is 26.184, and so you plug that in. Okay. 184. Okay? So we have this, for this, like, condensed circuit, we have all of our values figured out, but we still need to figure out this non-condensed circuit, the original one. Basically, since this is the same thing as this, we can kind of forget about it right now. So all we're looking at right now is this part, the parallel circuit. So it's only got 2. So you know that the totals for this parallel circuit are the values for the second resistor here, because these two are just condensed into this one. So we can rewrite that if you really want to, but I don't really want to. Basically, we have all 3 values here. And if you look, this is a parallel circuit, so in parallel circuits, the voltage is constant. So we found the voltage here, and it just so happens that the voltage here is the same exact thing for this resistor and this resistor. So we can rewrite that. So the voltage here is 26.184. So we rewrite that and put it here. So this is 26.184, and this resistance is 26.184. We can also plug that into our handy dandy chart. So we have, oh, did I say resistance? I meant voltage. Sorry. Don't mean to confuse you. So the voltage here is carried over to here. The voltage is constant in parallel circuits. So, yeah. So the voltage is 26.184 in resistors 3 and 4. So 26.184, 26.184. And then if you look back here, something that I didn't do at the beginning that I probably should have done, the resistance for this resistor is 4, and the resistance for this one is 6. So we have to plug that in. 4 and 6. So now all we have to find is the current for 3 and 4, and then power. But we'll get to that. So to find the current, we can again use our handy dandy formula, V equals IR. So we know that for resistor number 4, we know that the resistance is 6 and voltage is 26.184. So we just do 26.184